Working principle of milk chilling plant demo and operator duties of refrigeration and air conditioning technician. Upon completing the refrigeration and AC technician course, students will be qualified to work in various industries, including milk production. This module will cover the major components of a refrigeration and air conditioning plant in a milk production facility. Compressor. A compressor is a mechanical device that increases the pressure and temperature of a gas by reducing its volume. In our plant, we use two types of compressors. Booster compressor. This compressor provides an initial increase in pressure. It is typically used in systems where a multi-stage compression process is required to achieve the desired refrigeration effect. The booster compressor helps in optimizing energy usage and improving the overall efficiency of the refrigeration cycle. Screw compressor. Known for its high efficiency and reliability, the screw compressor uses two interlocking screws to compress the refrigerant. It is suitable for continuous operation, making it ideal for industrial applications like milk chilling plants, where downtime must be minimized. Screw compressors also have a relatively low maintenance requirement compared to other types of compressors. HP and LP cutout. High pressure HP and low pressure LP cutouts are essential safety devices in the refrigeration system. LP cutouts. These cutouts monitor the low pressure side of the system. When the pressure drops below a predetermined threshold, the LP cutout will stop the compressor to prevent damage due to low suction pressure, which could lead to refrigerant starvation and overheating. HP cutouts. These devices monitor the high pressure side. When the pressure exceeds a safe limit, the HP cutout will shut down the compressor to avoid risks such as refrigerant leaks or system rupture. In our plant, the low pressure stage uses screw compressors to compress ammonia up to 2 bar, and the high pressure stage uses 3 screw compressors to increase the ammonia pressure to 11 bar. Condenser. The condenser is a critical component that changes the state of the refrigerant from gas to liquid by removing heat. This process involves heat removal. The hot gas from the compressor releases its latent heat when it passes through the condenser coils. This heat is then transferred to another medium, typically water or air, which carries it away. Condensation process. As the refrigerant loses heat, it condenses into a high pressure liquid. This liquid is then ready to be expanded and used in the evaporator. Effective condensation is crucial for maintaining the efficiency of the refrigeration cycle and ensuring the refrigerant is in the proper state for cooling operations. Cooling tower. Cooling towers are essential for dissipating the heat removed from the system. Evaporative cooling towers. These towers cool the refrigerant by evaporating a small portion of the water, which removes heat from the remaining water. This method is highly efficient in terms of energy usage and cooling capacity. Closed circuit dry cooling towers. These towers use air to cool the refrigerant without direct contact between the cooling fluid and the air. This design is beneficial in environments where water conservation is important or where water quality is a concern. Receivers. Liquid receivers are storage vessels for excess refrigerant. Storage function. They hold refrigerant that is not currently needed in the system, ensuring that there is always a sufficient supply for varying load conditions. System balancing. By providing a buffer for excess refrigerant, receivers help in maintaining the stability and efficiency of the refrigeration cycle, especially during periods of fluctuating demand. Chiller or evaporator. The chiller serves as heat exchanger, heat extraction. The chiller removes heat from air, water, or other process coolants through the boiling of the refrigerant in the evaporator. This process is essential for achieving the desired cooling effect in the milk chilling plant. Efficiency. Efficient heat removal is critical for maintaining the quality and safety of milk products. The design of the chiller ensures optimal heat transfer and minimal energy consumption. Deep freezer. The deep freezer operates on the principle of evaporation. Evaporation process. The refrigerant absorbs heat from the surrounding environment as it evaporates, causing a cooling effect. The evaporated refrigerant then enters the compressor as a low temperature, low pressure vapor. Cycle continuation. After compression, the refrigerant is condensed and expanded, repeating the cycle to maintain a consistently low temperature. Deep freezers are crucial for preserving milk and dairy products at the required low temperatures to ensure freshness and prevent spoilage. Control panel. Control panels are the operational heart of the refrigeration system. Software control. Modern control panels are equipped with software that allows for precise monitoring and control of the refrigeration process. The software receives data from sensors placed throughout the system. Data analysis. The control panel provides real-time visual representations of system performance, enabling technicians to quickly identify and address any issues. This capability is vital for maintaining the efficiency and reliability of the refrigeration system. After completion of refrigeration and AC technician ITI, the operator work duties include service and checking of all equipments and electrical accessories every 6 months, descaling of condenser and water plant every year, cleaning of cooling tower every 6 months, daily checking of plant performance by noting readings in the charts.